So hi everyone, today we will be discussing question B Equalize from Codeforces around 9 to 4 of Dev 2. This was a good question in terms of thinking intuitively, and if you do the brute force approach of this question, it wouldn't be possible in 1 second in 10 to power 7 iterations. So today we will discuss the optimal approach of this question. If you haven't tried the question, please go through it once. I'll just explain the question first. So Vasya has two hobbies: adding permutations to the array and finding most frequently occurring element. Recently found that array A has decided to find out maximum number of elements equal to same number in array A that he can obtain after adding some permutations to A, right? And more formally, Vasya must choose exactly this permutation of length n and change the elements of array A according to the rule A of I plus P of I. So we are basically adding the permutation sequentially, right? After that, Vasya counts how many times each of the number occurs in an array A and takes the maximum of these values. You need to determine the maximum value he can obtain. So I'll just explain the question. Vasya basically has an array A. Some elements in it, and what is a permutation, and he adds some permutation P to it and gets some final resultant array with added permutations. So what is permutation? The definition of permutation is given in this paragraph, and this paragraph essentially says A of I plus P of I, like we are adding element by element, right? So what basically permutation is, as we are given that n is the size of array, right? So let's say there are 5 elements in the array, n equal to 5, then permutation would be a sequence of 1 to 5. Basically, more formally, permutation is a sequence of 1 to n where all elements are distinct. Like sequence can be 1 2 4 3 5, 1 2 3 4 5, or 2 1 5 4 2. Sequence should be less than n, element should be less than n, and you can like arrange them in any way possible. Just make sure they are distinct. That's the point of permutation, right? So moving forward, what we want to do is adding an element of array with some possible permutation. Let's say 2 1 3 4 2 1 3 4 5. So adding this element of array with 2, adding this element of array with 1, and so on and so forth, so that the final array we get should have maximum frequency. The element, I'll just demonstrate. Like let's say we get an array after adding we got an array like say 1 1 2 3 3 3 and some 4 5 4. Like calculate the frequency of each element. Frequency of 1 would be equals to 2 because 1 occurs 2 times here, and frequency of 2 would be just 1 because it occurs 1 time. Frequency of 3 would be 3, right? You get the idea. And frequency of 4 similarly would be 4 occurs 2 times first time, second time, so 2, right? So what we have to do is find maximum frequency like an element can get, an element of an array can get, right? So, and this array is obtained after adding initial element plus our permutation, resultant array. What we have to do, we don't have to find the permutation exactly, but we have to find the maximum frequency, right? Moving forward, so the what my intuition for this was, we know that size of array was n, right? And so permutation would be an element from 1 to n, anything from 1 to n, right? And where like p of I belongs to natural numbers. So you can add any element like this to an array 1 to n, anything from this to get resultant. So what I can say is minimum something I could get from after adding would be a of I plus 1 to a of I plus n, right? You have an element a of I, you are adding something to it to get resultant, right? And this number ranges from 1 to n, because this is how permutation works, correct? So this would be the range of final array after adding permutation. Take final array elements. This range would be dependent on element itself, so it would be different for all elements. And I'll tell you, and one more keen observation to note here was, see, let's take an example of discuss itself. Like we have 1 1 4 7, right? If like, and permutation can n equals to, as n equals to 4, permutation can be any number from 1 to 4, right? So basically if we have the same number and permutations are distinct, right? This would be p1 and p2. P1 is not equal to p2. When we add distinct elements to same number, the result would be different. Like this won't be equal to this after addition. So we can just discard the same elements, as we won't be able to get any like again the same element from it. For example, 1 plus p1 equals to x and x1, and 1 plus p2 equals to x2. What we want is to maximize frequency, right? So x1 won't be equal to x2 anytime. Think about it for a while. Thus there's no point in calculating for x2. We can just neglect our same elements. Okay, this was one observation. So basically just neglect same elements in array. Reason being, you won't get the same number because of the permutations addition, right? So, and second, what we would do, this is the main important part. Let's say you had an array like this, and like in test cases it was something similar to 7 4 1 4. We are just sorting it 1 1 4 7. Why sorting? Why does this intuition hold? The simple reason I'll say for sorting, as order doesn't matter. Order does not matter here. Like what we need is maximum frequency, and for calculating that we don't need the order of elements, so it would just make our work easier in this way. And I'll just get to the solution quickly. We had elements like this. We are just sorting them in this order. You'll get the reason why. And then the possibilities for this element would be our array was 1 1 4 7, and size of array was 4, right? And we calculated the range that a of I plus 1 to a of I plus n. So the values that our permutation, like final array, can assume would be 1 plus 1 to 1 plus 4 for first element, and we are just removing the distinct elements, removing the same elements, so this would be removed. And for 4 it would be 4 plus 1 to 4 plus 4. For 7 it would be 7 plus 1 to 7 plus 4. basically we are doing this operation. So we are calculating the range, right? That just means on number line a of I can lie between after addition of permutations, the final array would look like this: a of I plus 1 to a of I plus n. And similarly, this would be something for a of j plus 1 to a of j plus n, a of j plus 1, right? And some similarly more cases like that, right? So our value for a of I would be between this square, right? And for value of a of j, it would be between this. So this intersection right here tells us we can get this element like a of I plus some p1 equals to a of j plus some p2. This is possible because of intersection region right here, right? Because we are calculating the range of the final value. These are both the ranges of the final value, and this would be equal if the portions intersect. Think about it. As portions intersect, if portions won't intersect, you can add anything to the a of I, but you won't be able to match it with the a of j, right? So this was the whole intuition and idea behind it. You should consider the ranges from this range to that would be a of I plus 1 to a of I plus n. This is the range of final element, right? And values can be assumed. Values of final element can be these, right? So if we get the same value at this point, right, this point, so that would mean ki a of I would also assume this value and a of j would also be able to take this value, right? And then moving forward, so what we have to do is like pretty clear now. Let's we have an array. Initially we had an array, we sorted it. So let's just consider the set. In set, elements are distinct and they are sorted. I'm talking about STL set, right? So in set 1, I'm telling you to add the elements 1, 4, 7, let's say, and in set 2, we are adding element plus n to get the range. That would be just as 1 plus 4, 4 plus 4, 7 plus 4, 5, 8, 11, right? I'll just plot it on a number line 1 to 5, and then this would be, let's say, 4, 4 to 8, this is 7, 7 to 11, right? These are our intersection, maximum intersections, right? Like this. So now, like, let's see how can we find this intersection patterns, like on which distinct number we would get this pattern. So this, to explain this, whenever we have like this range is like this, what we would do whenever we find an opening range, right? This is an opening, this is a closing. I'll just mark opening and red for closing, right? This is the opening of the range, this is another opening, this is the closing, and so on. So whenever you find an opening, just increment the count, and whenever you find an closing, just decrement the count. How does this work? Like when you increment the count, that means ki one range has already started, one interval has already started, and whenever you encounter another opening bracket, that means ki also another range has started, and the previous one hasn't concluded. And whenever you encounter a closing of a range like rightmost index, then just decrement the count. That would mean that range has ended. Think about this for logic for a while. This is very intuitive and you must be able to think about it. Like, do it on a pen and paper, you'll be able to realize why this works. Okay, so that's it. So, and we had this set 1 and set 2, 1 4 7 and 5 8 11. Then what we would do now is to keep a track of count and find maximum count. That would just say maximum intersection, right? Maximum count would just signify कि we have more intersections in this place, right? And we need कि our final elements become equal to something which can be made from different elements, right? From a of 1 we can make this element, from a of 2 we can make this element, a of 3, a of 4. By adding different permutations pi, we're able to make this element x. So x occurs maximum times, and this is what we have to find, that how many maximum times that element can occur. So keeping the track of count would just give you the maximum possible intersection, and finding the max count is the maximum possible intersections, and that is essentially the answer, right? So to understand better, I'll just show you the code and get into the details of it. So getting into the implementation part, I'm taking the input of test cases right here, right? Taking the input of test cases and then the input of the array size, and I'm creating a set here which would store my distinct elements of the array itself, right? And after that, I'm inserting elements into a set, and elements inserted would be distinct, right? Now comes the main part. After inserting, I have created another set, and what I'm inserting right here is basically element of set like x plus n, which is the maximum value that my final array element can assume, right? This is the maximum value of permutation you can add to an element of array, so you would get the maximum value, and minimum value possible would be x of 1, right? Where x is element of set 1. Right, and moving forward, now I'm just calculating the count in this part. I'll just go through it. Answer would store my maximum count, stores maximum count, right? And whenever I encounter an element in my original array, I'll just increment the count by 1, which would mean opening of a range, right? And whenever I'll compare like this line auto remove set dot begin. What this essentially means is that smallest element of set 2 would be just my first closing range, right? Consider it as of brackets, this range is, right? This one right here, this thing would be my smallest closing bracket, and I'll just compare my opening bracket with the smallest closing one to check if I'm in range or not. I'm still in range or not. So moving forward, if my element is equal to greater than or equal to my smallest closing range, then I would just subtract the count. That would mean that one range has ended. This range has ended right here. We are going into the new range. So this would just signify this. And why are we using greater than or equal to? Remember, our set we created was from x, right? Set 1 and set 2 was x plus n, right? But our range is from x plus 1 to x plus n. So even if we encounter x as our smallest closing range, then we would subtract our count, like decrement our count, and remove that closing range. What erase function will do, here RMB is my element to be removed if my opening bracket is greater than my closing bracket, right? If this is the case, let me think. Right. So if this is the case, my closing bracket comes first, then I would just decrement the count in, like, this is the closing actually what happened, and this is opening, right? So if my closing bracket comes first, then I'll decrement the range, the smallest closing bracket, and I'll just continue and remove this one. I'll remove this from the set. This would be removed, and we would just further keep going, and our answer variable would store equal to maximum of answer and count. Basically, answer is storing maximum count here, right? And we are printing our answer here, correct? This would give you the maximum frequency of an element that can occur in an array. So that's it. Thank you. You can tell if you have any doubts in the comment section.